Hi, I'm Edwina Lee. I work for RVIC as a director of business division, and RVIC is a fund foundry of Taiwan, and we devoted in developing fund technologies and designing CJK funds. And we're celebrating our 30th anniversary this year. It's great to have a chance to talk to you on the internet today, and I hope all of you are fine and healthy during the lockdown, and hopefully to have a chance to see you in person in the near future. And today I'm going to share a topic that all of us might encounter when working on cross-script apps or text editing. So my topic is some problems happen on apps or user interfaces when applying Chinese fonts. I will go over the issues below in my presentation. First, the compatibility of fonts and symbols using on cross-script apps. Second, how to determine default line spacing of apps. Third, the influence that setting default Chinese font height might bring. And last, some advices for the design of UI text layout. So first, let's talk about fonts and use in early days. IBM PC didn't support processing Chinese in early days, but from the 80s, with the popularity of using PC, several companies started to develop plug-in Chinese systems for DOS. But how these systems work were actually capture the characters on the screens to change ASCII code into Big 5 as graphics. It made Chinese word processing very complicated, especially when changing lines or aligning left or right. On top of that, inherit the display of fixed lines from DOS. PC could only display bitmap fonts of 16 times 15, and bitmap fonts were used on many embedded devices. Microsoft launched traditional Chinese Windows 3.1 in 1993. It started to support vector font TrueType, accompanied with Microsoft Word 5.0. Users finally could process Chinese in the way of what you see is what you get. And when Chinese and Japanese online fonts were first launched, the numbers and symbols were designed half-width like bitmap fonts. And later, influenced by Latin fonts, the numbers and symbols are designed proportional. Font heights are always made according to the size of EM square, so the line gap is very small, and the descender of Latin glyphs are limited. This picture shows one of the famous Chinese system on DOS, ET, Yitian. It used bitmap fonts. And this is a picture of the UI of Windows XP installer. The line gap is very small, so we could see how the font height of system font was set up. Then we'll talk about flat fonts for embedded devices UI. Flat outline fonts are designed for embedded devices that support multi-scripts. In order to use on UI, glyphs, characters need to be designed flat to fit the UI. It always happens when using Chinese with Latin or some complex scripts on software or the UI of embedded devices. Since the font heights are different from scripts, it's hard for UI to handle, and the client might ask for the same font height for all scripts. As you see the picture, some of the glyphs on the upper picture are not inside the UI, And after we flag the glyphs, they could fit in the UI. And here we'll talk about tables related to font height in Font Spec. Okay, OS2 and Windows metrics table, including S-typo ascender, S-typo descender, and S-typo line gap. And US Win Ascent, US Win Descent. They are mainly used on Windows. HHEA, horizontal header table, including ascender, descender, and line gap. And software on Mac might access this table. And about the value of metrics, you could find a couple of articles on the internet, and in our process of productization, we refer to the value that Karsten Luke proposed, as the slide shows. Microsoft TTSpec version 1.66 recommended the average line gap value should be 7 to 10% units per EM. And after OpenType 1 version 1.4, the recommendation of typo line gap is 20% units per EM. And RFIC starts to modify our font matrix, including ascender, descender, line gap, in order to increase the default font height. And if the font include diacritic symbols, the font height might exceed 120% of the font itself. Okay. So here are some problems on apps that design for cross-script added display might happen. The pictures are captured from the app Daily Notes of iOS. This app accesses the line gap value from HHEA table, and generally the parameter is 0. We used a Chinese typeface Maokai to edit text on the app. The left one with line gap value 0 on HHEA table, and the right one with the value 200. You can see when we raise the line gap value, there are more spaces and looks better. So when you change the value of the line gap, it works on daily notes. While applications such as Illustrator, InDesign, or Photoshop has their own mechanism of setting line gap, so these apps won't be influenced by line gap related font matrix values. But they have functions allow users to adjust the line gap. So for Microsoft Word, it's more like daily notes. Once you change the line gap value in HHEA table, you can see the difference. And then I have some case studies of the influences that update font height brings. This is a case study that one of our clients' software influenced by font matrix value when calculating font size and position. The left picture shows how the characters should look like and where they should stay. While on the right picture, you can see the font size is smaller and the phrase is not centered. To solve the problem, you might need to fix the program of its way to calculate or to restore the original font matrix value. So when you want to center a Chinese phrase, it's recommended to access an as typo ascender of font matrix as the font height of Chinese characters. It's always set as 880 and minus 120 when EM is 1000. Okay, another case study. It happened on Unity development interface. The left is original layout and the right one is the new layout. You can apparently see that the phrase is vertically going down. To solve the problem, you can set up the accent calculation mode of import setting in the font file and choose face bounding box matrix. Then you could avoid the vertical shifting caused by a center or line gap value. If you want to center a phrase on the UI, you could use bounding rectangle like the example of Unity face bounding box matrix. Then some problems on text editing apps. Take daily notes of ours for example. The Unicode of the bullet marked in red box is U plus 2043 as a hyphen bullet. And normally it doesn't exist in any Chinese or Japanese character set, including Big 5, GB2312, GB18030, Gs 0213, or Gs 127. So like the system font of Mac like Pingfang and Windows like 正黑 雅黑 do not support, and the only exception is Japanese Medio. The app uses San Francisco. It's a system font for Latin, Greek, and Cyrillic alphabets, and a variety of other typefaces for other scripts, but it doesn't support Chinese or Japanese. That's why when you edit in Chinese and choose the hyphen, it falls back to San Francisco. So when UI designers design apps that will be used in cross scripts, it's better to consider the bullets and numbering and choose those can be found in most of the character sets. Then I'll talk a little about the punctuation. Is smart punctuation smart? Okay, in Microsoft or Adobe InDesign, Illustrator, there's a function called smart punctuation or typographer's quotes. It will automatically change the punctuation of ASCII into full width punctuation and leads to excessive space. Smart punctuation adjusts space automatically. Here are some Chinese typefaces for you to refer to Arial and Calibri. The optical adjust function could narrow the space but not perfect. Manual adjust is recommended. Smart punctuation doesn't do well, but fortunately you could turn it off. In Microsoft Word, choose File, Document Setup, and do one of the following. Then click OK. To use straight quotes, deselect Use Typographer's quotes. Sorry that I used Chinese interface to show this page because I don't think Latin users have a big chance to do it. Then some problems to cloud fonts. So how well does software support cloud fonts? The famous cloud font platform you might have heard, like Adobe Fonts, Monotype Sky Fonts, and Arvik Ivan Cloud. It's our cloud font service, mainly provide Chinese. And of course, there are more. And since we operate our own cloud font platform, we found some authoring tools don't support cloud fonts, so that some of our clients couldn't be satisfied. For example, like some subtitle software like Open Caption of Adobe Premiere Pro. But we found like its version 14.1 starts to support Mac, and Arctime Pro 2.3 and 2.4, and CAD like AutoCAD, DriveSite 2017. Okay, then I would talk about a problem about zero of Chinese numerals. In this page, I have three groups of numerals: Arabic numerals, mixed Arabic Chinese numerals, and traditional Chinese numerals. Let me explain a little for you to understand. Most people and institutions in China and Taiwan primarily use the Arabic or mixed Arabic Chinese system for convenience. And traditional Chinese numerals used in finance, mainly for writing amounts on checks, banknotes, some ceremonial occasions, some boxes, and on commercials. Here, I would like to raise an issue of mixed Arabic Chinese numerals of zero. It looks like the zero in Arabic numerals, but it's bigger, flatter, and wider. In this slide, I will show you three zeros. First is the zero in Arabic numerals, and this is only a symbol of circle. And this one is what we should choose in mixed Arabic Chinese numerals. While most people do not know the difference, and some of them always choose the left one, which is the Arabic zero. Some with sense who know the difference would choose the middle one, the white circle, at first, because in Microsoft Office it's prioritized. Although the right one exists in most Chinese fonts, while the style is not always matched the style of the Chinese typeface. Input methods of 注音 and 仓颉 do not support it. The only way to display it is to enter the Unicode or to insert symbols. Here's an example that in Chinese we use mixed Arabic Chinese zeros. And here you could see when using mixed Arabic Chinese numerals how they should look like when choosing different zeros. The right one is the correct zero in Chinese numerals. As technology evolved, font technology too. For fonts, we have a lot of new things like variable fonts, but hardware, software, apps, they change so much faster than fonts. So not only Chinese, I believe we will face more challenges to make fonts compatible to all kinds of application. So thank you for your time to listen to my presentation, and if you're interested in it and would like to have a further discussion, you could reach me at the email on the screen. Bye bye.